Dear students, let us study about trigonometry today. It is the study of relationships between angles and sides of right-angled triangle. Let us consider a right-angled triangle. Let's draw a right-angled triangle. The side which is opposite to 90 degree is called hypotenuse. Let's consider the triangle to be ABC, right angled at A, and AC will be the hypotenuse. In trigonometry, the angle that we are considering, we call it as theta. The side which is opposite to angle theta, we call it as opposite side. And the side which is adjacent to theta is called as adjacent side. So angle C, we call it as angle theta in this right angle triangle ABC. Now let us draw one more right angled triangle. And let it be an isosceles right angled triangle. That is, two sides of the triangle ABC will be same. It is right angled at angle B, and AB and BC, let's call it as one unit, and AC is a hypotenuse. In an isosceles triangle, the angles opposite to the equal sides will be equal. The sum of all the three angles in triangle will be 180 degree. Angle B is 90 degree, so angle A and angle C are 45 degree each. Now let us calculate the length of side AB. So by Pythagoras theorem, the square of hypotenuse will be equal to the sum of square of other two sides. So the other two sides are 1 square and 1 square. So which is 2. So the length of AC is root of 2. Now let's draw one more equilateral triangle. Okay. And in equilateral triangle, the length of all sides will be equal. Let us also draw a perpendicular from top vertex to the base. The equilateral triangle, let's consider the side of each side to be 2 units. So AB is 2 units, AC is 2 units, and the point where the perpendicular touches the base, let's call it as D. The length of side BC is 2 unit and length of DC is 1 unit. Now let's draw only a part of triangle another time, that is triangle ADC, and it is right angled at D. In equilateral triangle, all angles will be equal. So angle B and angle C will be equal to 90 degree, and angle A is also 90 degree, and the perpendicular bisects the angle as well as it bisects the side BC. So each of the bisected angle is 30 degree. So if we draw a small triangle ADC right angled at angle D, then angle C will be 60 degree and angle A will be 30 degree in the triangle ADC. So the length of DC is 1 unit, length of AC is 2 unit, and let us calculate the length of AD using Pythagoras theorem. By Pythagoras theorem, we know that the square of hypotenuse will be equal to the sum of other two sides. Hence, AC square is equal to AD square plus DC square. AC is 2 unit, so 2 square is equal to AD square plus 1 square. So AD square is equal to 4 minus 1, which is 3, and hence length of AD is square root of 3. In trigonometry, we have 3 basic ratios. It is sine. First one is sine, and we shortly abbreviate it as sine. Second one is cosine, and we shortly abbreviate it as cos. And the third ratio is tangent, and we shortly abbreviate it as tan. We always consider one angle, and let's assume that angle to be theta in trigonometry. The formula for sine theta is opposite side by hypotenuse. And the formula for cos theta is adjacent side by hypotenuse. We have already seen which is opposite side and which is adjacent side for the considered angle theta. The tan theta, the formula is opposite side by adjacent side. Now let us find what are all the values for sin theta, cos theta and tan theta for some of the common angles like 30 degree, 45 degree and 60 degree using the triangles that we have already drawn. The value of sin theta and cos theta for 30, 45 and 60. Let us draw a table. For sin theta, let's consider triangle ADC. So angle A is 30 degree and the opposite side is DC, hypotenuse is 2 and adjacent side is root 3. Sin theta is opposite side by hypotenuse, opposite side is 1, hypotenuse is 2. Now let us consider sin 60. For 60 the opposite side is root 3 and the hypotenuse is 2. Hence sin 60 is root 3 by 2. To find the value of sin 45, let's consider the triangle ABC, in which for 45 angle the opposite side is 1 and the length of AC we have found it as root 2. Hence the sin 45 is opposite side, that is 1 unit, divided by hypotenuse, which is root 2 unit. Similarly, let us find the value of cos theta. Let's consider the triangle ADC. Cos theta is, the formula is adjacent side by hypotenuse. So for 30 the adjacent side is AD and the unit is root 3 and the hypotenuse is 2. To find the value of cos 60, angle C is 60 degree and the adjacent side is 1 and the hypotenuse is 2 in triangle ADC. Hence cos 60 is equal to 1 by hypotenuse 2. To find the value of cos theta, cos 45 in triangle ABC, the adjacent side for 45 degree is 1 and the hypotenuse is root 2. Hence the value of cos 45 is adjacent side 1 by root 2. So these are all the values, sin theta and cos theta values for some of the common angle 30, 45 and 60 from these basic two triangles.